Hey there folks, Root Beer here looking at question number 9 on the 2010 Manitoba Math Contest. Solve for x and y. X plus y plus xy plus 2 equals 0. X squared plus y squared plus x squared y squared minus 16 is equal to 0. Interesting. Okay. So, things that I notice, we could pull the constants over to the other side, and we'd get x squared plus y squared plus xy all squared equals 16, and that would make sense. And that tells me that at least one of x or y is non-zero. And we could pull the negative 2 over to the other side, although I think I've seen this expression here, I think is very similar to, so if I wanted to, I could factor out those x's and I get 1 plus y. So I would need 1 plus y here. Well, I got y plus 2. So what I'm going to do is I'm going to rewrite this as x plus y plus xy plus 1, and we'll bring one of those 1's over to the other side. And now this can factor as x plus 1, y plus 1 is negative 1. Nice. What, if anything, does that tell me? Not entirely sure, but I like it. Okay, and I think we can do sort of the same thing, but with the squares. It's minus 16. But I can change the minus 16 equal to 0. I can put a plus 1 here, and it'll be minus 17. So I'll bring the 17 over to the other side. And I will have x squared plus y squared plus x squared y squared. So that'll be x squared plus 1, y squared plus 1 is equal to 17. Okay. Does that help me at all? I mean, it's entirely possible that this is not the way to go about this question. But, I mean, it just seemed like the most logical thing to do there. I guess, I'm pretty sure we can just sort of get a quadratic in x. If I'd say x plus 1 is, well, actually, no, we'll say y plus 1. Y plus 1, because we want everything in x. So y plus 1 is negative 1 over x plus 1. So y is negative 1 over x plus 1 minus 1, but I'm going to choose to write that as minus x plus 1 over x plus 1. Negative 1 minus another 1. So that'll be negative 2 minus x over x plus 1 is equal to y. Okay, now I can square that. And get y squared is 4 plus 4x plus x squared all over 1 plus 2x plus x squared. And then if I add 1 to that, so y squared plus 1 is now 5 plus 6x plus 2x squared on top, 1 plus 2x plus x squared on the bottom. Okay, so now I will get a full expression in terms of just x. So 17 is x squared plus 1 times whatever it was I just said. I think it was 5 plus 6x plus 2x squared all over 1 plus 2x plus x squared. Alright, let's just double check. Yeah, okay. So then 17 plus 34x plus 17x squared is going to be equal to 5x squared plus 30x cubed plus 2x to the 4 plus 5 plus 6x plus 2x squared. Alrighty, I'll bring it all over on the one side. So 0 is 2x to the 4 plus 30x cubed, 5x squared plus 2x squared, so that's going to be 7 minus 17, so it'll be minus 10x squared, plus, it'll be just 6x minus 34, so minus 28x, and then 5 minus 17, it'll be minus 12x. Okay, well, divide by 2. That should be minus 12. And that should be minus 6. Okay, so that's a quartic equation. And I don't have the quartic formula memorized, nor should anyone, really. In theory, I guess solving this would answer. Is there anything obvious to do for this question? X being negative 1, we get 1 minus 15 minus 5 plus 14 minus 6. No, that's out the window. We'll try 1. So that'd be 1 plus 15, so that's 16. Minus 5, that's 11. Minus 14, no, that's not going to work. 0 certainly isn't going to work. Alright, last ditch effort, we'll try 2. And then I think maybe I have to go back to the drawing board. 8 times 15 is 120. Minus 20, minus 28. Yeah, there's no way that's working. Okay, so I have no idea how to factor this. And that's okay. Is there anything else I could try here? So I can't think of an integer answer. No harm there. If only these were x squared minus 1s. That would be really nice. But perhaps I approached this one from the wrong angle. So what else is there to try? So x is 4, we get 17, and y is 0, but that'd be 5 and 1. That's not going to work. It really is a shame that this is not x squared minus 1. And y squared minus 1. I really wish it was. But there's nothing I can do about it. X squared plus 1 and y squared plus 1 just do not factor. They don't. I did copy it down, right? Yeah? Okay. Well, I mean, it has to solve that quartic, incidentally. It does have to be a solution to this. It just, I can't think of, 15 there is really causing me problems. I can't even think of what the graph of this might look like, or how many solutions there might be, and that's not good. Alright, we'll just make sure I did rearrange and solve for y correctly. Yep. I did square that correctly. Yep. Add it on by 1 correctly. Yep. Multiply it by x squared plus 1. Yeah, that all followed through, and we got 17. Well, I guess simply there's another approach I need to take. Alright, well, let's try again. When you get stuck, don't delay, just try again. So minus 2, no, it's plus 2. And then x squared plus y squared plus x squared y squared minus 16 is equal to 0. Now there's x squared plus y squared here, and the fact that there's an xy here makes me think maybe I should rearrange this equation into x plus y is negative xy minus 2. Or, no, I guess I should do xy is negative x, negative y, negative 2. Then 2 times that would be 2xy is negative 2x minus 2y minus 4. And if I add this to this equation, I got x squared plus 2xy plus y squared plus 2x. I'm just bringing it all onto one side because I don't know exactly where I'm going to need it. Plus 4 plus x squared y squared minus 16 equals 0. And now this here, the whole point of that was that this becomes x plus y squared. But of course, x plus y, not only that, it's x plus y squared plus 2x plus y. And we can say plus x squared y squared minus 12. But x plus y can also be written as negative 2 minus xy. So I could write this as negative 2 minus xy all squared plus 2 negative 2 minus xy plus x and y all squared minus 12 equals 0. And then this becomes 4 plus 4xy plus xy all squared minus 4 minus 2xy plus xy all squared minus 12 equals 0. These 4's will cancel out, as will 2 of these xy's. And then I will have 2xy all squared plus 2xy minus 12 equals 0, and that at least is a quadratic I can deal with. Divide by 2 on both sides. So I might say something like, let z be xy, then we have z squared plus z minus 6 equals 0. This is much better progress. Z plus 3 z minus 2 equals 0. So that tells me xy is 2, or xy is negative 3. And x plus y we said was negative 2 minus xy, so it's either negative 2 minus 2 or negative 2 minus negative 3. And those are negative 4 and 1. So now I need x plus y to be negative 4 and xy to be 2. Can that ever happen? I don't think so. I mean, I'm willing to be wrong, but I don't think it can happen. and x plus y being equal to 1 and xy being equal to negative 3. Well, I'll tell you what, we can make the quadratic out of this. So we'll say x plus y equal negative 4, xy equal 2. So that would be y is 2 over x. So we got x plus 2 over x is negative 4. X squared plus 2 equals negative 4x. X squared plus 4x plus 2 equals 0. So that's what we need to have be true. But I can't think of any two things that multiply to 2 and add to negative 4 there. If I could, I would have solved it a while ago. So we'll quadratic formula. But this is much better. This is much more productive than what I originally tried. Sometimes you just don't see the right thing. So x is negative b plus or minus square root of b squared minus 4ac all over 2a. So it looks like it has a solution. It's just negative 4 plus or minus square root of 8. And that's going to be negative 2 plus or minus root 2. So they add those, and then so y would be negative 2 minus or plus root 2. And they do multiply by difference of squares to get me 4 minus 2, which is 2. Okay, so that's some solutions. And I bet you actually, if I took this polynomial here, it would divide that original quartic that I created. If I did polynomial division, I bet you it would. Okay, so that gives me two solutions. And wouldn't you know, we are going to have 4 different solutions for x. That's nice. So our other possibility is x plus y is 1, xy is negative 3. So that tells me x squared minus 1x minus 3 is equal to 0. So we get x is negative b plus or minus square root of b squared minus 4ac all over 2a. And that's going to be 1 plus or minus root 13 all over 2. Something seems wrong there. Yeah, definitely something's amiss. So if I multiply this by y, then, y's got to be the other one. Negative plus, minus plus. So did I set this up wrong? Well, if I multiply these two out, I'll get 1 squared minus 13 squared all over 2 squared. No, okay, so that'll be 1 squared minus 13 all over 2 squared, and that will be negative 12 over 4. So yeah, okay, that is negative 3. So that gives us our other pair of solutions. And we did just want x and y, right? Solve for x and y. So x and y can be one of 4 possible pairs. We could have 2 plus or minus root 2, and then 2 minus plus root 2, or 1 plus or minus root 13. I think there was a minus sign there. And negative minus plus root 13 all over 2. So we do get 4 pairs there. And that all adds up. It's not a minus. It's a. I was wondering because they didn't add up to the 1 that I wanted them to. There we go. And so that wraps up question 9. A bit of a rough start there, but we got it in the end. And if we were better at factoring quartics, and no one really is, so, but if we were, we would have not had as much trouble with that one, or at least I wouldn't have. Okay, so we got one more question to go in this contest, and that will be question 10, and we will deal with that in the next video. We'll see you guys later.